Hi everyone. Now we are going to discuss about solid waste disposal. Since the beginning, humankind has been generating waste, and with the progress of civilization, the waste generated became a more complex in nature. Today, along with the air, the earth, that is soil, is more polluted with the generation of non-biodegradable solid waste. The increase in population and urbanization is largely responsible for the increase in solid waste. So here comes to the solid waste. So what is the solid waste? The solid waste is the unwanted or useless solid material generated from combined residential, industrial, and commercial activities in a given area is being defined as solid waste. And this solid waste is going to have different compositions and different properties. So what are the sources of this solid waste? Obviously, the solid waste includes the residential, commercial, institutional, and industrial activities. Okay, and the solid waste is mainly classified into two types. One is the hazardous and non-hazardous. Hazardous we are not going to discuss here. Okay, so all non-hazardous solid waste from a community that requires collection and transport to a processing or disposal site is called as refuse or municipal solid waste. So this refuse includes both the garbage and the rubbish. So what is a garbage? The garbage is mostly food waste which can be easily decomposable. Whereas the rubbish is mostly dry materials such as glass, paper, cloth or wood. And this garbage, as I told you, is most putrescible, that is most easily decomposable, whereas the rubbish is not. And the trash is nothing but the rubbish that includes the bulky items like such as your old refrigerators, washing machines, all these things where they require special collection and handling, isn't it? So what to do? This garbage generated in households can be recycled and reused to prevent creation of waste at source, that means at our home only, and reducing amount of waste thrown in the community dustbins. So basically 4 R's are going to be followed for waste management. What are those 4 R's? One is refuse, that means initially we are supposed to refuse of creating the waste, and suppose if you are not going to have the other option, then you have to make it to be of reuse, then you have to go with the recycle, then you have to reduce. So these are the 4 R's where we are supposed to be followed for waste management. So you are supposed to have a reduce, reuse or recycle, any order. These are all going to be of interlinked in a circle manner. So recycle, reuse, reduce, anything. So the methods of waste reduction, waste reuse and recycling are preferred options when managing waste. So these are the methods. They are mainly environmental benefits and that can be derived from the use of these methods. They reduce or prevent greenhouse gas emissions. So if you follow these 4 R's, you can prevent the greenhouse emissions and reduce the release of pollutants, conserve resources, save energy, reduce the demand for waste treatment technology and landfill spaces. So therefore, it is advisable that these methods be adopted and incorporated as a part of the waste management plan. Okay, what is this waste management plan? So the waste management is the collection, transport, processing, recycling. So what is meant by processing means waste treatment. Okay, recycling and disposal of waste materials, usually once produced by human activity in an effort to reduce their effects on human health or local aesthetic or amenities, being called as waste management. And this waste management is going to have many have a number of different concepts which vary in their usage between countries or regions, so it is getting different from one to the other. The important waste management concepts are the waste management hierarchy, where we are supposed to have the reduce, reuse, recycle. Okay, the second one is resource recovery and the third one is recycling. So here the aim of this waste management hierarchy is to extract the maximum practical benefits from products and to generate the minimum amount of waste. So what is the main aim of this waste hierarchy? We are supposed to extract the maximum practical benefits from the products that we are going to uh, give it as a solid waste and to generate the minimum amount of waste. So here is a waste management hierarchy that you are going to see. So disposal is the least favored option. So what is the most favored option? It's a prevention. So as I told you, you're supposed to refuse it first. So if it is not possible, you have to go with the minimization, that the thing, then you have to reuse it, then recycle it, and then reduce, that is the energy recover. If that is also not possible, then we have to go with the disposable. So this is how the hierarchy is going to be. Most favored option is the prevention, least favored option is the disposal. And the total waste management, I told you the definition of the waste management is the collection, then transport, and then processing, that is a waste treatment, and then recycling, then you are going to have the disposal of the waste. So these are all going to be of an interlinked process or in a circular process to remove the waste from the society. Okay, and then this waste management, fundamentally, the solid waste management covers the social, economical, technology, political, and administrative dimensions. So these are all are involved in the waste management. So first, waste minimization should be done. That is a social activity that we are all responsible here. And then waste recycling, so where the economic factor, that means the economic factor is going to be dependent upon the countries. And then political, so how the political people are going to be involved in recycling this process or establishing the waste management uh, institutes or all these things. Then administrative, how effectively it is going to work. So these are all going to economic, political, and administrative things are going to be involved in the waste recycling process. Then finally, waste disposal, how these all going to give the advances in the technology to dispose the waste without any adverse effects or disadvantages. So this waste management is not an isolated phenomena that we can easily compartmentalize and solve with innovative technology or engineering, but it is related to resource consumption patterns, income levels, as I told you, and socio-economic cultures issues also. All these issues have been brought together on a common platform in order to ensure a long-term solution to our urban waste. So because we are the one who are generating, that means the urban people are the one who are generating the most waste in the countries. Then coming to the methods of solid waste disposal and management. So we are having several methods, out of which we are majorly or commonly employed strategies for urban waste we are going to discuss now. So one is the landfill, okay, and second one is the incineration, and the third one is the composting and anaerobic digestion. And we are having the other types also, like mechanical, biological treatment, pyrolysis, and then gasification. But here we are going to discuss only these three in detail. So let's see what are these three first, and then we will go in discussion of about these three in detail. Okay, so let's come to the first one, landfill or solid waste sanitary landfills. So solid waste sanitary landfills process is simple, clean, and effective. So what we'll do in this procedure means we are going to have the layers of compressed with some mechanical equipment and covered with the earth, that is nothing but the soil, and leveled and compact. Then it is going to be exaggerated and microorganisms act on the organic matter and degrade them. So here in this process, the refuse depth generally should be of 2 meters, and facultative bacteria hydrolyze complex organic matter into simpler water soluble organs. So don't get bothered about it. I will discuss this in detail now. Then incineration method. So obviously the name itself is saying incineration. So obviously you are going to have the burning of it. Okay. So incineration method is suitable for combustible refuse. high operation cost and constructions are involved in this procedure. This method would be suited in crowded cities where sites for landfilling are not available. Okay, obviously if there is no land available, they have to burn off. So it can be used to reduce the volume of solid waste for landfilling also. Then composting process, which is a very best process in the solid waste disposal. So composting process is similar to sanitary landfilling, and it is popular in developing countries. And this decomposable organic matter is separated and composted in this procedure. Yields are stable and products and good soil conditioners. They can be used as a base for fertilizers even. So these three we are going to discuss in detail now. So let's come to the first one, sanitary landfills. So as I told you, sanitary landfills are the sites where waste is isolated from the environment until it is safe. Okay, so let's see the picture, then you'll get the idea. So here is the area where they're dumping the waste. Okay, and after dumping they are going to be made into the layers, and the mud is going to be sprayed on it, and it is becoming a cell. So let's see how it is going to happen. So as I told you, it is considered safe when it is completely degraded biologically, chemically, and physically. So the four basic conditions should be met before a site can be regarded as a sanitary fill. So that means if you want to select a sanitary landfill, so there should be four conditions. So what are those conditions? Full or partially hydrogeological isolation should be there. Second one, formal engineering preparation should be there. Then third one, permanent control should be there. And fourth one, planned waste placement covering should be there. Placement and covering. So these are all the things that you have to keep it in mind before selecting a place as a sanitary landfills. Okay, then what is a landfill? So landfills are generally located in urban areas where a large amount of waste is generated and has to be dumped in a common place. Okay, unlike an open dump, it is a pit that is dug in the ground. So here are the pits you can observe. So they are dug in the ground. The garbage is being dumped and pit is covered. Okay, thus why we are going to cover the pit? Because to prevent the breeding of flies, rats, all these things. So at the end of each day, a layer of soil, okay, a layer of soil is scattered on top of it and compressed. So this is how you are going to have a nice compressor. Thus the garbage dumped every day becomes a cell. So after the land is filled, the area is covered with a thick layer of mud like this, and the site can thereafter be developed as a park or parking lot. So you can have this place usage for either developing a nice park or a parking lot. But these sanitary landfills or the landfills have many problems. So all types of waste is dumped in the landfill. So they are not going to separate the garbage, rubbish, all these things separately, because it is not possible, and everything is going to be dumped off. And when water seeps through them, it gets contaminated and in turn pollutes the surrounding areas also. Okay, when the rains comes or the water seeps, they are getting into the groundwater, okay, and they are going to be contaminated. So this contamination of the groundwater and the soil through landfills is known as leaching. And the landfill leachate consists of water containing dissolved chemicals such as salt, heavy metals, and often synthetic organic compounds also. In addition to contaminating water, along with this, water landfills release pollutants into the air. Anaerobic microbial process generate greenhouse gases such as nitrous oxide, methane, and carbon dioxide. So these are the ways that are being generated because of this sanitary landfills. So then what should we do? So we have to go with the advancement of creating this sanitary landfills. So that's how we had got the modern sanitary landfills, which are designed for minimal impact on the environment. So here is the thing, first of all, what they are doing, let's see. So here in the modern sanitary landfills, uh, they are going to be of having some sort of both short term and long term groundwater protection. Okay, so the landfill site selection is based on geological and soil type. So whether the soil is having porous nature, all the things have to be studied first, and then depth of the water table and use, so that also have to be considered. So by selecting these two options, they are going to select a sanitary landfill area. And after that, what they are doing, the bottom of the landfills are going to be lined with materials that are impermeable, such as plastic or clay, and also built over impermeable soil. So this all the things are going to be made with the impermeable soil or clay or plastic, whatever it may be. In addition, provisions are made to collect and analyze the leachates and gases that emanate from the landfill. So this municipal solid waste containing a variety of enteric pathogen and fecal coliforms and some sort of streptococci. Okay, these are all going to be had during the composition, that is decomposition. After burying, they are going to release a high temperature. That's also another, that means more heat will be generated. So those are all some sort of problems that are because of this sanitary landfills. So one more problem with this related landfills are less oxygen is available to the garbage as it is compressed very tightly. So I told you after every layer we are supposed to have it, and finally they are going to be compressed. Biodegradable materials do not compose in landfills. So it's not that much easy for the biodegradable substances to decompose easily. Okay, then generation of the methane gas is one of the major disadvantage from this sanitary landfills that I told you already. Gases like nitrous oxide, methane, carbon dioxide, all these are being released into the atmosphere, and that's how our greenhouse gases are releasing, and we are getting the greenhouse effect, that is global warming. Then the next type of this solid waste disposal is going to be the composting. So the composting is a method for treating solid waste in which organic material is broke down by the microorganisms in the presence of oxygen, where it can be stored safely, handled and applied to the environment. So environment means for our plants, crops, everything. So this decomposed organic matter is made up of leaves, like grass clippings, like fruits, vegetable scraps, all these things. And this composting offers the obvious benefits of resources efficiency and creating a useful product from organic waste that would otherwise have been landfill. So this, what is a compost? So compost is useful particularly as organic manure which contains plant nutrients such as nitrogen, phosphorus, and potassium. And this composting is going to be the integral part of waste process and can be studied in broader headings like open composting, enclosed composting, anaerobic digestion, and vermiculture. Okay, so through the vermiculture you are going to do the composting, that is composting technology. Now this composting can be done, so that both the things of open composting and closed composting. Open composting is also called as land treatment, and in closed system you are not going to have the open, it will be closed in environment. So the open land system can be inexpensive method, but the temperature fluctuates from summer to winter. Whereas the closed system is preferred over the open land system, where you can control air is supplied to maintain the microbial activity. Then this is the how the total composting process is going to occur. So this is the raw product that is containing different types of minerals, nutrients, or this organic matter. Okay, and now it is going to be mixed up, and now it was kept in a compost pile. What is this compost pile? I'll tell you. and then it is going to be curing in the presence of oxygen. It is getting curing, and intermittently it is going to be turned off to supply the oxygen throughout it, and finally this is going to be the organic matter is getting decomposed. We are going to get the microorganisms, all these things. And during the process of this composting, you are having the release of these gases, that is carbon dioxide, nitrous oxide, and other gases, even the heat and the water vapor also being released. So in nature, organic wastes are broken down through a contamination or a combination of biological and chemical process. So biological agents. So what are the biological agents? Like worms, insects, fungi, bacteria, and other microorganisms chew up the materials which are further transformed by oxidation. That is what in the presence of oxygen. And reduction and hydrolysis also occurs, that is exposure to water also. The basic composting pile, so this is a basic compost pile, is made up of layers of organic matter, okay, sprinkled with a little soil and fertilizer, keep moist, and turn to keep oxygen going through it. So always it is going to be turned on. The composting process can speed up by making the size of the organic matter smaller and by turning the pile frequently. So if you are going to turn it, so obviously it is going to supply the oxygen, and the decomposition or composting will be done very fastly. And at the same time, lesser the amount, more the composting will be faster. So there are four basic ingredients in the compost pile. So as I told you already, the first one is going to be of carbon, that is organic matter like leaves, provide the food for microorganisms. Then the second one, the nitrogen comes from gas, that is grass clippings, so the small bits of grasses and dead green plants, and provides the energy microorganisms need to break down the carbon. Then water and oxygen, which microorganism needs lots of to do their job. Okay, so these are the four basic ingredients in a compost pile that are essential to do this composting process. And then for types of composting, so we have the different types of composting. So for large scale commercial composting, the aerated pile system is carried out in closed buildings to facilitate the control of odor emission. So generally during the composting process, we'll get a very unbearable smell, so or odor. So that is going to be controlled in a large scale commercial composting. In these systems, forced aeration with regular turning is used to create good composting conditions. Then coming to the tunnel composting, it is performed in closed plastic tunnels of about 30 to 50 meters long and 4 to 6 meters width, okay, and height. Such tunnels have been in operation for many years for the composting of sewage, sludge, and domestic waste. And even this is going to be specialized, used in the preparation of specialized substrate preparation for mushroom production. Okay, so we had a video about the mushroom production also, you can see it. And then coming to the rotating drum, so rotating drum system in various sizes have been used for composting mainly domestic waste. Okay, so the large drum process is useful for wettish organic waste, that means uh, water mixed one, wettish organic waste, and the small drum systems have been widely accepted for small quantities of our garden waste, okay, which can readily be used for recycling. Then coming to the next one, microbiology of wasting. So here the composting as aerobic solid substrate fermentation utilizes a complex range of indigenous microbial activities and involves succession of various bacteria, actinomycetes, and fungi. So what are all this doing here? So the microbial organisms that are developing, so they will develop or their development is going to be influenced by the substrate composition and the temperature. So initially, mesophilic, mesophilic means the one which grows at the normal temperature. Mesophilic bacteria, fungi are going to be predominant in this composting. and their metabolic activities generate heat. So because of this mesophilic bacteria and the fungi, they will generate some sort of a heat. So the rise in temperature ultimately suppresses their growth and they become suppressed. Now what happens? The thermophilic bacteria and thermophilic fungi will rise in number. The temperature continues to rise up to about 70 to 80 degrees centigrade, okay, which encourages the proliferation of other thermophiles also. And from this point, you think that maybe it is going to increase more. No. From this point, the temperature slowly again declines. That means it is going to come again to 40 to 60 degrees centigrade, where thermophilic fungi become involved, especially are like humicola, aspergillus, chitomium, etc., where whose cellulases and hemicellulases are responsible for substantial amount of plant cell. Okay, so now that means the plant material containing this cellulose, all these things are going to be degraded by this thermophilic fungi. So finally, after about 20 to 30 days of initiation of this composting process, the second mesophilic phase will enter. So initially we had a mesophilic phase, that means normal temperature bacteria, and again now slowly the temperatures comes down and it is coming to the normal temperature. So obviously the second mesophilic phase will come, and as the material becomes recolonized by a large number of our mesophilic microorganisms. Okay, so apart from the fundamental benefits of compost, we are readily eliminate, reduce, recycle, treat, and dispose the waste. It also enhances the soil fertility by the application. So there are some advantages or important influences of compost on soil characters, like will enrich the soil conservation, it will supply the nutrient recycling, and then it is also going to be enhance the water nutrient retention and releases. Okay, so this is all about the composting. Then we'll move to the anaerobic digestion. So anaerobic digestion is an alternative method to some sort of problem of creating the landfilling or of organic waste. Okay, and it is also like composting only, but it occurs in the absence of oxygen, so that's why we call it as anaerobic digestion method. And it is naturally occurring process of decomposition and decay by which organic matter is broken down into simpler subchemicals under anaerobic condition. And this process is mainly brought about by the mesophilic as well as the thermophilic organisms. And we are going to have the process of conversion of this organic matter into simpler chemicals by anaerobic conditions is going to be occurring in 3 steps. So let's see what is happening in these 3 steps. During this process, the first step includes the decomposition of the waste. So that means hydrolysis of the waste. So this step breaks down the organic material to usable sized molecules such as sugars and amino acids. So first of all, the organic matter is going to break down into the simpler molecules such as sugars and amino acids. Then coming to the second step, this involves the conversion of the decomposed matter to the fatty acids and alcohols. And finally, in the third step, that is the final step, a set of microbes convert the alcohols to methane gas. So this is all that happening in the anaerobic digestion, and this anaerobic digestion is going to be carried in a anaerobic digester. So you can see in the figure, so waste is being dumped out and that digestion is occurring and the slurry is being removed and the gases, mainly methane gas, is going to be collected in the pipes and they are going to be used as a fuel. Okay, so this is all about the anaerobic digestion. Then we'll move to the difference. Just have a look of the difference between the composting and anaerobic digestion. So in the composting, organic matters, air is required, but in the anaerobic digestion we don't require any air. So here also organic matter only, but there is no involvement of the oxygen. And digestate is the one that is being generated because of this anaerobic digestion, but here the compost is the one which is coming. And what are the gases that are being released in the compost? Many gases like carbon dioxide, then your nitrous oxide and the things. But here In the anaerobic digestion, mainly methane gas is going to be produced and carbon dioxide in the lesser quantity. Then moving to the vermicomposting, which is very, very important one in the study of enriching the soil fertility. Okay, so but we are not going to discuss in detail here, just we are seeing about the composting process. So vermicomposting technology utilizes earthworms for decomposition and production of vermicompost, and it is a latest biotechnology where application of these earthworms are used for decomposition and production of vermicompost. And here the earthworms is made for combating the waste disposable problems, for minimizing the pollution effects, and to get useful products from the waste. And vermicompost is going to create a fine black granular compost. So you can see here how nicely it's a black, called casting. So these all things are called as the black powder is going to be called as a uh, castings. So worm castings are an excellent source for slow release soil nutrients for plants, and they also act as an excellent soil additive that prevents the cacking of the soil, that means breaking of the soil into potted uh, uh, caking of soil in potted plants. And the most significant effect of earthworm in agroecosystems is the increase in nutrient cycling, particularly nitrogen. So this is how the vermicomposting is going to be done with the help of our earthworms. So here you can see this is the vermicompost, and this is the these all are going to be the earthworms which are involved in composting our organic substances. So that's how we finish the solid waste disposable of having the mainly of how many types? Three types we discussed. One is the sanitary landfills, and then we had gone with the composting, okay, and then incineration. So incineration is directly burning off. So that's all about the solid waste disposal and its management techniques. Thank you.